All right, so now let's turn those bullet holes into an application here. So we can actually do this to our wall once it has a bullet hole in it. Okay, and yeah, I'll try to wing it. I might have to go back to my canned example, but let's see how we do from scratch here. Okay, so I've got this particle network. It's doing its thing. Okay, now the problem with this is that it's very hard to work with time. Okay, because our time is dependent on each previous frame, right? So after almost every particle simulation, okay, see, I can't scrub backwards, I can't view it, I can't do some of the other cool things we're about to do with it either. So I'm gonna have to cache this to disk. Now, caching it to disk is something that Houdini people do all the time. You can cache any stage of any operation to disk. It's just like, say, Nuke, where you could write out your image at any stage to disk. That you can do that in Houdini too, and with caching. Okay, with geometry caching. So this will be our first cache. All right. So I'm going to do a ROP output driver. All right. Now a ROP. Let's see. So if SOPs are surface operators, if POPs are particle operators, what do you think a ROP is? Sorry? Yes, it's a render operator. So in Houdini, there's really two main kinds of rendering. There's rendering images using Mantra, which is Houdini's renderer, or there's rendering geometry, which is really just saving this result to disk as what's usually a BGO or a binary geometry file. Okay. You can also write .objs if you want to. Okay. So if you want to import them into Maya or whatever. Okay. So here I'm just gonna take this into my ROP output driver. This is just a short form for like something you'd get in a ROPS network. See, if I go into my ROPS network, now I have all of my render things I can do, and what this would be a geometry render node. But let's not worry about that yet. This is easy. So this is just a ROP output driver. Okay. And I'm going to give this a path. Okay, so you have to put this somewhere on disk that's not going to like fill up your desktop with 100 files, okay guys? So you want to make a folder for it, or just not desktop, but wherever you put it. So here I'm just going to make a new folder. I'm going to call this my particle cache. Okay, so I'm in my desktop on a folder called My Particle Cache. That's where I'm going to put it. Okay, I'm not going to just put it on the desktop because you're going to have your desktop completely flooded with files. Okay, don't do that. All right, so I'm going to give the file a name, My Particle. Now, this is important. If I just do this .bgo, it's going to overwrite the same file like 200 times. Okay? You don't want to do that. You want to actually give this a name with a $F in it. $F is the variable for the frame, the current frame. Okay? So that's how we could do this as well, although it'll take a lot longer. You could cache it to sequential OBJ sequence as well. Okay? But for right now, I'm just going to try BGO. Okay. So once I've got my $F in my name, see, I can evaluate that too. You see it turns into 1 because I'm on frame 1. See? Okay, so I'm going to write that out. Now, that was quick. If this was a big particle simulation, it would take longer. Okay? I would say your average geometry job at a studio would take probably 20 minutes for, a shot or something on the render farm. Okay, so now I'm going to read this back in. So I'm going to file, and this is that pesky little X guy that we've been seeing the whole time, right? It comes default when you make a geometry node. We're actually going to use this guy now. All right, so I'm going to load that back on disk. Now, if I wanted to, I could just select this from disk, and I've got my files. Uh-oh. Just happened. It only wrote out one file. Ah. You have to set your frame range. So instead of any frame, you want to render your frame range. You go from 1 to the end, okay? So here I'm going to do f_start and fn. Okay, because it's not always going to be like 1 to 240. Okay, you might start your shot at 1001, go to the shot length. So always better to use these variables. This is the f_start, the start of the timeline. This is fn, is the end of the timeline. Okay. Now I'll write it out. There we go. That took a little longer. Okay. All right. Now I can go backwards. See that? Okay. Now, if you really want to get fancy, I probably wouldn't hard code this path in my scene. Why is that? Yeah. Any other reason? Okay, what happens if you have multiple versions? You want to have multiple versions of the same effect. Okay, so in this case, I'm actually going to say, all right, I'm going to copy this parameter, this link, this reference, and I'm going to paste a relative reference. Now what that did is it actually copied that parameter to where if I change this, for any reason I version up or whatever, then I don't have to worry about changing this one as well, okay? Because it's just it's giving me this channel string expression. It'll go and get that. Okay. All right. So do that if you're brave. Okay. So now we can scrub back and forth and we can play our particles. Okay. All right. So we have these different groups, right? We have holes, we have sparks, we have bullets. So if I wanted to just get the sparks, who wants to take a guess at what node I would use? We've used this before, today actually. Delete. There you go. Okay, so to isolate different parts of something, we're going to use the delete. Okay? Now, this time we use the delete, it's going to be procedural because we have these procedural groups on there, right? So we know exactly what we're doing. Not just a number for a polygon. So here I'm just going to use delete, and up here under group, I'm going to go and grab my bullets. And I'll uncheck enable. There we go. Now, it's still giving me a warning, and that's because there are no primitive groups or primitives. These are just points. So I'm going to do change the entity to points instead of polygons. Okay. So now it deleted the bullets. But I don't want to delete the bullets. I want to keep the bullets. So I'm going to do non-selected. Okay. There we go. All right. So I'm going to label this ISO bullets. Okay. Now my next delete, ISO sparks. My next delete, ISO holes. Okay, so here's all the holes, here's all the sparks, and here's all the bullets. Alright, and the reason we're doing this is because we're going to do different things with each one, right? We want to put geometry for a bullet on the bullets, we want to render our sparks as sparks, and we want to use our holes to form our bullet holes in the wall, right? So now that we have these groups, we can derive all these things out of our system and use them to finish up our shot. Okay. So I'm going to give it some nulls. What am I going to use these nulls for? if I want to go to another object, help me out here. All right, remember this from week 1? Yeah, that's handy, right? Okay, so we just have a placeholder to tell our next systems, hey, we want to grab this, right? Okay. Okay. So we've cached out our geometry, separated it into its 3 pieces, and given it some placeholders to reference from another system. Okay, so bullet holes. I'll call this particle system. Call this bullet hole system. All right. So, what are we going to need for the bullet hole system? We basically want to take the wall and make bullet holes in it. What pieces do we need from the other parts of our scene? The wall. And one else. Sorry, what? Yeah, the bullet particles, right? Good. Okay. So, object merge. Alright, so let's see, where's our wall? Here's our wall output. Got that. Merge wall. And we should see output bullets somewhere. Wrong one. Holes. Okay. Okay, so our holes are animated. You can see our holes appearing on our wall. Now, I'm going to do a little trick here that's very powerful if it's used the right way. Okay? We're actually going to grab the end result of our system. Okay? So I actually want to cut this box all at once. I don't want to have to keep cutting it every single frame. I just want to cut it once. Wouldn't it make sense to just grab the final result, all the holes, and cut it all at once? So for that, I only want the last frame. If I go to my merge holes and I do a time shift stop, we can shift it to the last frame. If I go, instead of $F, F end, okay, now no matter what I do, it's going to be the last frame. Okay, and you can get really creative with this stuff. Like, I've used these things all kinds of ways. Like, you could do like 100 here, and then merge them together, for instance. Oop. See, now I'm merging together like 2 different frames into the same thing. Okay, you can do all kinds of weird stuff. And you will need weird stuff to do certain effects. But for right now, end frame. Okay. Okay. Now, these, if I could use this to cut the wall right now if I wanted to. There's a really great tool they just added in Houdini 11 and 12. It's a Voronoi fracture. If I put my points in here, my box in here, we get our cut. Okay. Now it's not very good cut because I really don't have many points that I'm working with here. The way a Voronoi works is that it creates a noise pattern based on central points. Okay. So you can see how each cell is kind of mimicking where it would be in relation to these points. All right. Now, if I want lots and lots of fractures just around that area, what technique could I use from last week to get lots of points where each of these 1 point is? Well, if they were lines, I could resample them. That's a good idea. Scatter. Okay, that's good. We learned scatter and copy, right? So we could copy more points where those points are, right? We're trying to think procedurally here, okay? So on each of these points, I want a sphere. Okay. And I'm going to copy this sphere. So this goes in that one. This goes in that one. Okay, a little too big, huh? Transform. Sorry. There we go. Something like that, right? That's probably a pretty good size for a bullet hole. Okay. And we could scatter. Okay, well, we definitely have lots and lots of points. And if we wanted to, this would probably work a little bit better. A little too many points there. Okay, so we got some bullet holes. All right, now we've got lots of resolution there. I still don't really like the look of that. And the reason is because these scatters they don't have any points in the middle. So they have points on the edge of the circle, but not the middle. Okay, so for that I'm going to introduce a volume. Anyone know what a volume is? Okay, they're pretty cool, but they can be challenging to work with. It's a volume. We're going to work with more with that when we get into fluid simulations and fire simulations and stuff. It's basically like a 2D image. So we have our X and our Y, right? And your image can have channels like color and opacity and things like that. And a volume is basically a 3D grid. Okay? And that's really useful for fluid sims and various things that require a spatial representation. Okay, so in my sphere here, okay, I'm going to do a node in Houdini to turn this sphere into a volume. So ISO offset. All right, it did. It just turned it into a volume. I'm going to give it a little bit more resolution though. There we go. So now I have this 3D image of my sphere. Now if I do my scatter, now they're all through my sphere, which is really cool. Okay? And I probably have too many points I'm scattering. I'm going to try like maybe 30 points per copy. So my things get copied there, my bullet holes. And then I fracture my wall. Not enough resolution there. So here I'm going to actually be just kind of adjust it until I think it's going to be a good resolution to work with. Let's try 50. Not quite. Let's try 100. See, so you can really adjust any part of a Houdini system and see your end result. You know, it's really useful. Getting there. Let's try 200. Okay, that'll probably work. One more thing is that I probably don't want I don't want the whole wall, right? I just want this side of the wall. So for that, I'm just going to get this guy and delete just that piece of the wall. Okay. Well, these already should be on the surface though. Oh, they're on the wrong side. That was wrong. Okay, never mind. There we go. Yeah, I was looking at the wrong side. Okay. Okay, so that's pretty good high resolution fracture there. Okay. So you can see our original, and you can see each fracture that they made. Okay. All right. So I think that's probably complicated enough. There's one more piece to the system that'll actually cause it to deform, which is what we want. But for right now, I think this is enough. So so we start with a merge in our pieces. We merge in our system, cache it out, isolate your various pieces. Okay. Make a new node. Okay, so we merge in our bullet holes. And time shift that to the end. So end frame there. Okay. Next we make a sphere. Create a volume from the sphere. Make it small. And scatter points in it. And copy that to your end result, your bullet holes. Merge your wall in, and we're gonna use this wall and this pattern to fracture the wall. Okay.